So this is a continuation of the last video. And remember, you can always come and go in these videos. If you feel like you're ready to start on your homework assignment, you don't have to watch all of these examples. But if you get stuck, just know that these examples are here. All right, so we were in the middle of number 72. I ended by combining this bottom fraction into one fraction. All right, and then I'm going to go ahead and I'm going to take a look at sine squared plus cosine squared. Whenever I see this, I always reduce it to 1. So I have 1 minus sine squared theta over 1 over sine squared theta. And if you remember back to where I went through and manipulated some of my Pythagorean identities, if you remember, we had sine squared theta plus cosine squared theta equals 1. If we can manipulate this so that I can get 1 minus sine squared theta to equal something, then we could see what happens. All right, so I'm going to subtract sine squared theta from both sides, and I get cosine squared theta equals 1 minus sine squared theta. So I know that 1 minus sine squared theta equals cosine squared theta, so I'm just going to write that in place of this. So that is one of those identities that you have to start remembering, right? One of the alternate forms. And then I'm just going to multiply. This is a complex fraction. I'm going to multiply the numerator and the denominator by sine squared theta to eliminate this complex fraction. And I end up with cosine squared theta times sine squared theta. And that was probably one of the most complicated ones that is on your homework, because we started off by getting rid of those negative angles, using our negative angle identities to get rid of our negative angles. And then we just had a whole bunch of math to do because they wanted us to convert everything to sine and cosine. It may have been easier not to actually convert. But they want you to practice doing that. So how about this one? I like this one because when we go straight to converting, right, we don't have any squared terms. And as far as I can tell, I don't have any identities here that I can see. So I'm going to go straight to converting cosecant into sine of theta. And I like this example because it's an example of the fact that you can go ahead and find common denominators and do all of those algebraic things that you would have done back in our algebra sections to simplify an expression. So I'm going to find a common denominator, and I know my common denominator is going to be sine, so I need to multiply sine by sine over sine, so I get 1 over the sine of theta minus sine squared theta over the sine of theta. And this allows me now to combine this expression into one fraction, 1 minus the sine squared theta over sine of theta. And you should start remembering now that cosine squared theta plus sine squared theta equals 1. That 1 minus cosine squared or 1 minus sine squared is an alternate form of this. So if I subtract sine squared from both sides, I get 1 minus sine squared. And in the last example, we went and replaced 1 minus sine squared with cosine squared. All right, so now we're stuck at a point where it says to in the directions that we can't have any fractions, no quotients. So how are we going to get rid of the sine? Well, I think the easiest thing to do is to split cosine squared up into cosine theta times cosine theta over sine. And now when I do the math here and simplify this, I get cotangent of theta times cosine of theta. All right, so that's another trick. Sometimes you can split up those squared terms into just powers of 1. All right, so how about number 78? This is the last example I'm going to walk through. All right, so again, it does say that we should convert everything into sine and cosine, but I like to do my distribution first. It seems to make the problem easier. So I'm going to go ahead and just distribute to get cosine squared of theta minus cosine of theta secant of theta. And what do we know about secant of theta? Secant of theta is the reciprocal of cosine. So when I multiply two reciprocals, for an instance, here's an example, I get 1. Okay, so if you can remember that, you don't have to do your conversions, because if I did something like sine of theta and its reciprocal, I still get 1. All right, so I'm going to go ahead and do the conversion, but for a lot of you, multiplying two quantities that are reciprocals, you will always get 1. Okay, so now we have cosine squared theta, and again, if you recognize that these are reciprocals, you can go ahead and just make it 1. So now I get cosine squared theta minus 1. All right, so let's think about this. Can we reduce this? Well, I know that sine squared theta plus cosine squared theta equals 1. I need to manipulate this identity to get cosine squared of theta minus 1. So if I subtract 1 from both sides, I get this. Now I can move my sine squared theta to the other side by subtracting sine squared theta. So I end up with cosine squared theta minus 1 equals negative sine squared theta. So I'm going to go ahead and replace that expression with this. So this original expression equals just the negative sine squared of theta. And I believe that was the last example I have. Good luck on your homework. It should be fun. Remember, this is all about manipulating and looking for alternative configurations of your identities.